Hey everybody, Dr. Duncan here. This is the unit Climate Change 7, where we're going to explore some of the possible solutions to the water crisis that we're facing here in the Southeast in the coming decades, and in the water crises that are being faced around the world. In Climate Change 6, Unit 6, we covered watersheds, and we covered how we use watersheds and how climate change are affecting watersheds. And the principal focus was on the Southeast. In this next unit, Climate Change 7, we're going to look at several of the possible solutions for the coming water shortages. They're going to include more dams, groundwater, desalination, and water efficiency and conservation. And by the end of this, I think I will convince you that there's one option among these four that is absolutely by far the best. So let's get started. We're going to focus on dams first. Dams are our most powerful tool for managing rivers. We use them for primarily for creating reservoirs, which are large bodies of water held behind the dam. That's upstream of the dam. And those reservoirs, we use that water for everything from irrigation to industrial use to supplying water for cities and some other uses. We also use dams to generate electricity, a form of electricity we call hydropower. In some river systems, we use dams to control floods, to reduce or be able to control the amount of water that's moving downstream during storm events, to reduce flooding in communities and other human-occupied areas. And the reservoirs above dams are pretty popular in terms of recreation because they create large bodies of water for outdoor recreation such as boating and things like that. So these are these are not necessarily used in all places around the world, but dams are used widely for these purposes and many other purposes, and they're a very powerful tool for managing rivers and getting a lot of utility out of our rivers. Now, we have a lot of dams in the U.S. Dams are tracked, at least larger dams are tracked by the U.S. Army Corps of Engineers, and they maintain a database. And in that database, they have around 91,000 dams. I think they're actually getting close to 92,000 dams as the inventory becomes more complete. Just in the 8 states that I consider here as part of the southeastern U.S., we have over 17,000, almost 18,000 dams that are in the national inventory of dams. And you might expect, as I did, that a lot of these dams are for hydropower. But if you look at the stats, it's only about 2% of these dams are associated with generating power. A marginally important number are used for irrigation or flood and stormwater control, but the vast majority of dams in the southeast are primarily built for recreational purposes, 70%. Now it's important to clarify here that dams serve multiple purposes at once. So for example, a large hydropower dam, yes, creates electricity, but also provides a large lake behind the dam that can be useful for irrigation and also used for recreation. Okay, so dams serve multiple functions. In the database, dams are listed and they're listed here as you see these statistics. They're listed for their primary function. So 2% of dams in the southeast were built primarily to produce hydropower. 70% were built primarily for recreation and so forth. Now, in addition to these nearly 18,000 dams that are in the southeast, there's an additional almost 41,000 smaller dams that are not part of the Army Corps of Engineers database. These are dams that are smaller than the minimum size that the Army Corps keeps track of. And these smaller dams also have big impacts on our rivers and streams. If you add up these numbers, we come to somewhere near around 58,000 dams in the southeast in these 8 states. About 50 58,586 to be more precise if you add up those numbers. That's a lot of dams. We are used to seeing large bodies of water in the interior of the southeastern U.S. I can assure you that nearly every one of those that you've ever seen has been created by a dam. There are very, very few natural lakes in the southeast. There's only actually a few locations in the southeast where we have natural lakes due to geologic processes. The largest one in Alabama is at the Florida border, north of Tallahassee, Florida, called Lake Jackson. Pretty much all the other ponds and lakes that you've ever seen in Alabama and in adjacent states were created by putting a dam on a river or a stream. Okay, I want you to pause this video lecture and read this short summary about the negative impacts of dams. This is from an organization called International Rivers. They're an environmental organization, and they are definitely convinced that dams are a very bad thing for most rivers most of the time, as well as for the people living adjacent to those rivers. So you're not going to find a balanced comparison of the pros and cons of dams in this article, but you are going to find a very thorough inventory of the negative consequences of dams. And one of the reasons I have you read this page is because it takes an international focus, and it has more of a focus on the cultural impacts. The large dam projects throughout the world have displaced many people, usually people of the lowest socioeconomic strata, and oftentimes indigenous peoples that are living in remote areas where you can actually put in a dam, because you're not going to put in a dam where there's a city. And so there's a lot of these cultural issues internationally as well as within the U.S. about the building of dams. And this summary does hit upon those issues a bit more than what I'm going to cover here in the next few minutes, with a focus here on the southeast. So go ahead and pause the video and navigate to Moodle and pull up the PowerPoint file. Put your PowerPoint on full screen mode and click on this image, and it should take you to the web where you can watch this video. If not, there's a link in the notes for the assigned readings for the lab. And this is true for all of the videos and readings that you are assigned with this unit. Okay, so we're back now after watching that. I'm going to talk about some of these problems with dams and provide a little bit more context and detail. This image that you see at the top right is a really good summary of the negative impacts about dams. In the next slide, I show it to you in full so that you can read the fine print, which is hard to see on this summary slide. As you should recall from the previous unit, rivers carry much more than water. They carry sediment, nutrients, woody debris, energy, and they're also conduits for the migration of wildlife, especially fishes. And of course, if that's what rivers do when they're free flowing, then when you put a wall across a river in the form of a dam, you're going to be blocking the movement of those materials. So dams not only cause disruptions to what rivers do naturally upstream from the dams, but they also cause disruptions downstream from the dam. Another thing that dams do that's a little less obvious is that they change the natural seasonal pulses that you find in a river. So here in the southeast, we get most of our rain in mid to late winter through mid-spring. And that's during our times when rivers naturally would flood, carry lots of nutrients and sediments and woody debris, and to be deposited downstream and to help sustain ecosystems that are downstream, all the way down to the coast, where, if you recall from the presentation, the unit on sea level rise, we talked about how marshes and other ecosystems along the coast are building in their elevation, they're building in their height to keep up with sea level rise. And that sediment that rivers deliver to the coast is really important to that. But dams in many river systems throughout the world, and including here in the U.S., are blocking sediment flow. They're blocking nutrient flow and all these other things that help sustain ecosystems up and down the rivers and all the way along the coast. Okay, back to the fact that rivers have a seasonal component to them. During the mid to late summer and in through mid-fall, river flow in the southeast tends to be pretty low, with the exception of times when hurricanes come through. And it's during these times that that trigger certain biological functions of species that live in the river. For example, there are species of trees that germinate along the banks of rivers and in our adjacent wetlands during those times of year when water levels are low. Similarly, when water levels are high in spring and winter, when we're getting lots of rains, those are good times for many species of fishes to migrate in our rivers. So the point of this is that just as the seasons change in terms of the climate, rivers change following the climate as well. And many species of plants and animals have their natural biology in tune with those changes. So that when you put a dam on a river and start having humans decide when that water flows and not what happens naturally, you are removing a lot of the resources and the cues that are necessary for species to be able to complete their life cycles. Some species do just fine, but the more sensitive species are the ones that are at risk. One of the other things that dams do to harm biodiversity is that they isolate populations of species. So in other words, if you had a continuous population of a species, perhaps a species of fish, up and down a river, and then you put a dam across the river, then you've now isolated the upstream population from the downstream population. Upstream fish might be able to pass through or over the dam to reach downstream, but unless you've taken some measures to provide a way for the fish to swim upstream, the upstream population will not be able to reach the downstream population will not be able to reach the upstream population. And so dams have become very effective barriers to prevent migration of species in rivers, which in the southeast we're mostly talking about fishes, but in some other parts of the world it includes other organisms as well, including things like river dolphins. And it's for these reasons that here in the southeast and throughout the world, we have actually lost many dozens of species to extinction. They're gone forever as a result of dams. Sometimes dams are the smoking gun that actually snuffed out those species. Sometimes dams are a contributing factor. We have many, many, many more other species that are in decline, that are in danger of going extinct. So these endangered species, many of them are put at risk, sometimes principally because of dams, and sometimes dams are a contributing factor. So if you're concerned about the conservation of species in the southeast and elsewhere in the world, then you should be concerned also about dams. Okay, here's that slide so you can study it on a bigger scale and read the blueprint, which gives you a summary of some of these problems that dams create. I already talked about fish migrations, but let me put them in a little bit of a historical context here in the southeast. You've probably heard about salmon and how salmon migrate up rivers at the end of their lives to spawn, and then they die, and they do that after several years of living in the ocean. Those salmon are, of course, commercially very important, and for these reasons, those populations have received a lot of federal dollars and state dollars and conservation attention to try to keep those populations thriving and healthy, because there's excuse me, because they're so commercially important. What most people are completely unaware of is that the southeast used to commercially harvest many species of fish that did similar migrations up the rivers. That included sturgeon, which was harvested for primarily for the eggs that the females were carrying upstream to spawn. And that, of course, sturgeon are the source of caviar, which is the reason that we were harvesting them. It also includes species that were harvested for their meat, including shad and river herring and striped bass and a few other species as well. These species would make epic migrations up the rivers in the spring. There's Native American populations timed their activities around these rivers because they would harvest a lot of these fishes, and then they would the fishes that they didn't immediately consume, that they would preserve by smoking them, so that they'd have them throughout for many months into the future. Euro-Americans that colonized also took advantage of this, and in many cases put so much pressure on these fish populations that they have reached near extinction levels. And so the U.S. Fish and Wildlife Service and other federal agencies and state agencies and conservationists and biologists, et cetera, are really trying hard to bring back populations of shad and river herring and sturgeon and others. So these are some epic migrations that used to happen in the southeast that we can restore if we put enough, if we prioritize that enough. And we'll be talking a little bit more about that a little bit further. Okay, so all of this, the reason we're talking about dams is because dams are often thought of and seen as a solution to water crises in a region. And for sure, dams have helped out many people in many parts of the world, including here in the southeast, by providing more water security so that you don't have to rely on the seasonal changes and what that can bring, because sometimes that can bring periods of low rainfall or low river flow. But by having a dam on a river, you can back up that water and store that water and then pull it out as needed. And so dams have been really important for the economic development of many regions of the world, including here in the southeast. So here we are in the year roughly around 2020, and we're looking at looming water shortages here in the southeast. They're not as dramatic as you see out west in the western United States, but they are of moderate intensity that we're going to be looking at. And in addition, you've got rising human populations. So for these reasons, and also to encourage further economic development and growth, there have been many discussions in the southeast about adding more dams to the landscape. The problem is that there's a lot of issues that come along with building dams and running dams or having them in operation. And in terms of biodiversity, damming the remaining rivers that are not yet dammed would be absolutely devastating to conservation of species. So we've got these potential conflicts between what wildlife species need and what people need, or at least what some people need, or at least what some people think they need. And you'll see what I mean when we get to that in the next few minutes. To begin with, let's start asking some hard questions about should we be preparing for water shortages by building more dams. And one of the biggest, if not the biggest argument against dams has nothing to do with biodiversity. It has all to do with dollars. Dams are exceedingly expensive to build. Dams that are erected here in the U.S. these days cost anywhere from tens of millions of dollars to hundreds of millions of dollars. And what will happen is that a developer or a local government will say, hey, we want to build this dam, here's how much it's going to cost. But by the time the project's completed, which is usually anywhere from like 10 to 15, sometimes more years later, you've run into a lot of cost overruns. It winds up costing us a lot more money. And I've got some examples here for you from here in the southeast, some recent dams that were built. Hard Labor Creek in Georgia, starting estimated cost was $41 million. That's a lot already. But the final cost of that dam, $350 million. There's a couple more examples here to illustrate that this is not just a one-off kind of problem. This is a chronic problem when it comes to building dams and other large infrastructure projects like this. So then you might wonder, well, who pays for dams? Is it just the government pays it, and so I don't have to worry about it as long as we get water, everything's cool? Well, unfortunately for those of us that rely on water, we pay for those dams. So the people that pay for the construction of the dams are the ratepayers. Those are the people that are paying your local water utility for the water that is captured and used behind the dam. And so in communities where they have built dams, those folks are paying a lot more for water than in communities where they have not built a dam recently or any other similar structures. Some of the costs of paying for dams also goes to taxpayers. The way this works is that that people loan governments money in the form of buying bonds, and the government promises to pay back that money plus a little bit of interest. That extra money and paying back that interest, as well as the money that was originally loaned, that's part of the government's obligation as part of the deal. And where does that money come from? It comes from taxpayers. So either way, whether you're a ratepayer or you're a taxpayer or both, it's the local citizens that wind up paying for those dams. So when you start talking about infrastructure projects in the tens of millions of dollars to hundreds of millions of dollars, we're talking about a lot of money that future citizens for many generations to come are going to be obligated to pay. If you need a little brush up, a little summary of what is a bond, a municipal bond, and how that works financially, I got a link here that you can follow from the PowerPoint slide. Here's a picture of a dam under construction. This is the Hickory Log Dam in Georgia, and this dam ran up a cost of $100 million by the time it was done. Again, just to sort of illustrate how expensive these things can be. Okay, another reason why dams might not be such a good solution is that by bottling up water on the landscape in the form of a large reservoir and having that water spread out with a lot of surface area exposed to the sky means that you're going to lose a lot of that water to evaporation, much more loss to evaporation than if that water was flowing downstream. The estimates are that in the southeast, that a typical reservoir in a typical year loses 1 million gallons of water per acre per year. So 1 million gallons, that's pretty easy to conceive of because you're familiar with what a gallon is, I think, like a gallon of milk. Imagine 1 million of those. That's a lot of liquid. Now, what is an acre? Well, I got this little silly cartoon to the right to illustrate that an acre is approximately the size of 16 tennis courts. Okay, so these reservoirs, of course, quite huge, and we're talking about a lot of freshwater loss to evaporation. Now, when is it that we need fresh water most? Do you remember that from Climate Change 6, the unit? Climate Change 6? Well, it's during our dry years and also during droughts. Droughts, of course, being extremely dry periods that last for many, many months. And it's during those times when we need our water most, and that's also during those times when evaporation peaks and exceeds this value of 1 million gallon per acre per year. Those rates are much higher during droughts because it's hot and the atmosphere is very dry and sponges up that water via evaporation. Some other problems that dams create. Because they don't let sediments pass downstream, at least most dams do not, the sediment winds up accumulating behind the dam. Well, this creates a problem because as that sediment accumulates behind the dam, it takes up the volume of the reservoir that you were counting on to store water. So this would be like filling up your fridge with bricks and not being able to use all of your fridge for storing the products that you need to keep cold, right? So that would be a big problem. And so dams over time and the reservoirs wind up losing their efficiency in terms of being water storage features because of this. Another problem that we see with dams is that the woody debris and other organic materials that get trapped behind the dam and trapped underwater, they wind up decaying, and in the absence of being in contact with the atmosphere, and therefore in the absence of oxygen, the decaying produces methane. And as you might recall from several units ago, methane is a very potent greenhouse gas, trapping one molecule trapping about 25 times more heat than any carbon dioxide molecule. This is particularly a problem in the tropical regions of the world, but any reservoir that has trapped a lot of organic debris, and that includes, by the way, all the trees and other organic material that gets trapped underneath the floodwaters when the reservoir is created. When that happens, you're going to have the methane produced, and of course that contributes and accelerates climate change. There is also a long list of very complicated and sometimes tragic cultural issues associated with building dams. For example, the many indigenous peoples around the world, including Native Americans here in the U.S., have tribal lands or formerly occupied lands in the river valleys along our rivers. And they have lost access to many of their culturally important sites as a result of them being flooded and now underwater. There's also issues in areas of like in the Pacific Northwest, where the Native American tribes rely on the salmon migrations to come up rivers each year as part of their culture, but also part of their sustenance and their harvest of food. And by having dams on the river and those dams not being effectively passing the fish upstream, it has had an impact on the perpetuation of their cultures and their livelihoods. So there's issues like that around the world, especially, and I'm going to repeat myself here from earlier, a lot of dams that have been built in the more remote regions of the world because that's where you have a lot of unoccupied land. That doesn't mean the land isn't completely unoccupied. Oftentimes it's occupied by people of lower socioeconomic strata, and quite often those are indigenous peoples, and they have lost a lot over the years to the building of large dams around the world. The other things I'd point out about cultural issues is that dams are one use of a river. There's other uses of a river that include recreational uses that are impeded by having a dam on a river, such as canoeing, rafting, kayaking, other forms of boating, and that sort of thing. And then there's also property rights issues. If the government wants to put in a big old dam somewhere, they got to get that land from somewhere. If the land's already in the public domain, then you have issues of like, well, how best should we use that land? Because some people might be very excited about using it as as a reservoir for water, and others might enjoy using that land for other reasons. If it's private land, then people are often basically forced to sell their land at fair market value in order to create enough space for the reservoir. The Tennessee Valley Authority, for example, did a lot of this last century in order to create their very extensive system of hydroelectric dams and reservoirs. And it was there was a lot of social strife, a lot of people were very upset about that. And so we're not even talking about environmentalists here. We're talking about people being forced off of farms that had been in their family for many generations, for example. All right, so all of this to say that there's some very culturally complicated issues about building dams. And so that is one more reason why dams are not such a great solution to the water crisis. Along those lines, I want you to look at this video from the PBS NewsHour that talks about the water shortages in California with regard to agriculture and proposals to use dams to store more water to sustain the agriculture in the state. It's a really good segment because it gets into a lot of the issues in depth and presents multiple sides, both pro and con, on this issue. There are a few aspects of the argument about dams that are not brought up by the video, so after you've watched it that first time, look back at your notes and compare your notes to other sections of this unit and see where there's some discontinuity, because there's some important issues that were not brought up in this video that I want you to be aware of. So for all the reasons that I just outlined and a few others, there actually has not been a lot of dams built in the U.S. very recently. Let's check out the statistics. This graph is showing a timeline on the x-axis by decade, and we are looking at the number of dams that were built across the years, pretty much by decade. And the map inset at the top left shows you the areas that have had, in the U.S., the states that have had the most dam building. What I want you to notice, first off, is that in the most recent years, we have seen a tapering off, a very steep tapering off of the number of dams being built. And that's for several reasons. One, we have a greater environmental awareness these days, ever since the 1970s. And so more and more of the public and our leaders see dams as not being a very good solution to solving problems of water water shortages. But the other issues have to do with the expense of dams and those issues that we talked about. And then another big one here is, of course, the fact that we are kind of dammed up most of the rivers that can be dammed, that provide the most value to society by damming. So there's not a lot of really good rivers left to dam. There's plenty more that could be dammed, but not as many as there used to be. So we kind of used all the easy spots on our rivers to build dams, and the ones that are on the fringes are going to be more expensive and provide less value to fewer people. Now, I also want to point out that there's other problems of dams that we haven't talked about, and that's that dams are not permanent. No matter how big and massive they are and look, those dams are not going to last forever. And when dams fail, and this is something that does happen, it can actually cause a lot of property damage, and in some cases cause the loss of human life. The older dams get, the more likely it is that they are going to fail. And dam building in the U.S. peaked here in the 1960s. And there was a spate of dam failures in the 60s and 1970s that killed many, many people. In fact, you go back further in time, and there was like some dam failures that actually killed thousands of people, and like entire small cities in the Midwest were decimated by a broken dam and flooding. And so dam failure is a thing. And so we do now have a better system of monitoring dams and checking on them and making sure that they don't, as they age, that they are continually maintained. But again, issues can come up. It's hard to, for example, inspect a dam when much of it is underwater, or there might be cracks deep in the concrete that you can't see, despite our technologies that we can use and to peer into places that we can't see with our own eyes. We still have limitations on what we can do. So these days, while deaths from dam failures are quite rare, about 20 dams fail a year, and about another 75 would have failed without intervention, meaning that they caught problems with the dams before they failed. So that seems to me to be a lot of dams, but it is a small fraction compared to the total number of dams, which, as we saw at the beginning, is over 90,000 in the U.S. Our dams in the U.S. are aging pretty rapidly. 70% of them that are in the Army Corps of Engineers database were at least 50 years old in the year 2020. And 85% of dams in the U.S. are nearing the end of their planned operational life. When dams fail, it can be pretty spectacular. This is an image from 2017 of this failure of the spillway of the Orville Dam in California. The spillway is a place on the dam that allows water to go from the reservoir down to the river during times of floods. And the spillway, there was a time of flood, and the spillway failed. And as you can see here in the picture, the erosion that was creeping up the spillway slope almost reached the dam at the top and would have caused a complete failure of the dam, but fortunately it stopped before it got that far. And fortunately there were no failures. But this was a good reminder that, like as I said before, dams are not a permanent feature. They can fail, and ultimately all dams will fail. It's just a matter of time. We get dam failures here in the southeast as well, especially when hurricanes hit and deliver a lot of rainfall to the region. In fact, I saw some stats recently that in South Carolina in 2017, during a major rainfall event that actually in this case was not associated with a hurricane, we had the failure of something like 30 or 40 dams in the southeast, or in South Carolina at the time. All right, so moving on, another reason that dams can be a problem is that, and especially for these old dams like the one you see pictured here that are no longer providing the function that they were built for. These are sometimes called derelict dams, and these dams can actually cause a lot of drowning deaths, because dams are just natural, or they're not natural features, but they're features in a river that just sort of naturally attract the attention of people. And people walking along the dam, such as this one you see here, the dam itself is covered with algae. The algae is slippery. They slip and fall. They hit their head, that kind of thing. Or kids are swimming around the dam, and it looks like it's a fun place and that sort of thing, but they get caught in these vortices below the dam, and then they can't get out. So some of these dams are known as drowning machines. It's pretty tragic. This particular dam you're looking at here in North Carolina has killed 18 people since the year 1984. And there are dozens and dozens of dams like this throughout each state in the southeast. So for all these reasons that aging dams present problems, that dams can be threats to areas downstream, etc., dam removal is a process that's or a trend that's increasing nationally. Here's some statistics on this. We're looking at over time on the x-axis from the 1940s to, looks like in this timeline goes up to 2014. We're looking at the cumulative number of dams removed by year. And again, so we're not looking at total per year, but we're the cumulative. So each year is added on to the next on the graph. And in the grand sum of things, when you look at like how many dams are out there and how many have been removed, this is really just a drop in the bucket. But it is a trend that is accelerating, and it's one that is widely expected to continue in the future, especially as our fleet of dams across the U.S. gets increasingly old and potentially ever increasingly more hazardous. Dam removal, most of these dams that have been removed are small because it's cheaper to remove a small dam. And in a lot of cases, these dams don't have owners anymore. So somebody's got to cough up the dollars to remove these dams. And that's one of the major impediments to this. And for that reason, most of these dams that have been removed are smaller. Another reason smaller dams are removed more than larger dams has to do with the fact that you have fewer people that are impacted by the removal of the dam. So it's a much easier process than when you're affecting many hundreds or thousands of people. There have been some large dams removed in the U.S., and that is another trend that's building. Here we see a picture from the Glines Canyon Dam in Washington State. It was removed in the year 2014, and this is on the Elwha River. This was the first large dam removal project in the U.S. And really helped illustrate that it can be done. And in the years since, biologists and others have been monitoring what has happened to the river and the regions around the river as a result of the removal of the dam. And biologists and others like me are thrilled to see the return of salmon and trout and other species migrating up the rivers and getting into portions of the watershed that they hadn't been able to get to for about 100 years or so. I've got a short video here for you to watch. It's a time-lapse video of the removal of one of the dams on the Elwha River. So you can watch that by clicking on this in the PowerPoint. Why don't you go ahead and do that now? Okay, in terms of large dam removal in other portions of the U.S., we've seen some large dam removal in the northeastern U.S., and I'll talk about one of those cases in a few minutes. But we have yet to see any large dams removed here in the southeast. But we have several examples of dams that are really old and maybe should come down, or dams that are really not providing much function, not providing much utility to people anymore, and that should maybe come down. This one is an example of being a dam that's really old. It was built in 1904. It's on the Chattahoochee River, which is the river that shares the border between Alabama and Georgia for much of its length, and the river that passes through Atlanta. This dam, Morgan's Falls Dam, is at the time of me recording this video lecture, is 116 years old. That's older than me. Now, one of the things that's happening with the removal of dams is that fish migrations are returning again. Remember all those fish migrations I talked about? Well, in cases where the fish populations were able to hang on, those fish populations are now getting access to spawning habitats up in the headwaters of the rivers that they have not had access to for dozens to sometimes over 100 years. I want you to watch this video from the National Oceanic and Atmospheric Administration that talks about their efforts to restore these great fish migrations across the U.S. And this is something that's happening everywhere from the Pacific Northwest to the northeastern U.S. and even here in the southeast. So go ahead and watch that video now, and then we'll come back and wrap up this talk about dams. Okay, so dam removal is something that's building momentum. A lot of different groups of people are now getting behind this movement, which in my opinion is a good thing to see. About 1,500 dams have been removed so far here in the U.S., but not as many in the southeast. It's mostly been in the northeast and the northwest. In the southeast, amongst southeastern states, Virginia, North Carolina, and Tennessee lead the way and have removed a couple to several dozen dams each as of the year 2019 or so. We have lots and lots of dams that are not providing any function anymore, that are hazards to people, and that are blocking fish migrations, et cetera, and that should come down. But like I said before, dam removal is expensive, and it does take several years of planning, and resources are tight, and there's not a lot of money that's available for this, unfortunately. In the southeast, we certainly have not seen any large dams come down yet. All the dams that have been removed are smaller dams. Most of the large dams in the southeast are for hydropower and are still, cranking out energy. So that's something that is going to be challenging for the region to deal with as we move into an era where we need renewable energy like hydropower, but at the same time we want to have some of these other benefits that a free-flowing river can provide. So removal of dams can restore ecological health to rivers and help prevent many species from going extinct. They can help deliver water and nutrients and sediment to the coasts, which can help sustain all that green infrastructure that we learned about in the sea level rise unit, such as marshes and reefs and barrier islands and beaches. The more of that we have on the coast, the better for us to withstand sea level rise, and also the more recreational opportunities and commercial fishing opportunities for people along the coast. And I also want to remind us all that removal of dams is inevitable considering age. So it's not a matter of whether, it's a matter of when. And in my opinion, the sooner the better. And along those lines, I'll wrap it up with this. I want you to read this very short summary about a scientific research paper that published the idea of decommissioning hydroelectric dams and taking them down to allow rivers to flow freely again. And instead of using, and not instead, but instead of the hydropower as the source of energy, using the reservoirs that will now be sort of exposed land that doesn't have any trees on them or anything, using those reservoirs to create solar farms. This would be places where you put arrays of solar panels to capture sunlight and turn that sunlight into electricity. This idea has a lot of merit in terms, at least theoretically, and for one reason, because you already have the electrical grid is already wired up to the hydropower dam. It should be pretty simple to wire that solar farm into the grid. and you would not have to create a whole new grid system to channel the energy from the solar farm to the electrical grid, because the grid is right there. Secondly, you already have the land dedicated to producing electricity, and so by switching over from a reservoir and a dam to create that electricity to a solar farm, you don't have to displace people from their private lands, or you don't have to repurpose public lands that people are using for other purposes. So that is something that was published in 2019. I'm not sure if this is going to catch on as an idea, but I find it a really really interesting idea, one that I think has a lot of potential. Okay, that wraps up this presentation about dams as a possible solution to the water crisis here in the Southeast. I think you'll see that I've become convinced, based on the data and the statistics and other factors, that dams are not the solution that we need. So that leaves us with the question, what else can we do? How are we going to provide enough water for everyone as the population in the Southeast grows and as climate change makes water less and less available? Stay tuned. In the next section, we'll talk about a couple more possible solutions, and we'll settle on one that actually would work really nicely.